Hey guys, welcome to another theory of computation tutorial. Today we'll be learning about some NFA examples, that is we are going to solve some NFA examples. So let's get started. So what are we going to learn? We'll look at just the revision of what is NFA. Then we'll look at 3 examples of NFA. If you have not seen my tutorial on what is NFA, what is the difference between NFA and DFA, I'll give the link, you can check it out. Alright, so let's start with the definition. What is NFA? Well, non-deterministic finite automata, also called as NFA, consists of 5 things. First is the number of finite states Q, then a finite set of inputs sigma, then we have a transition function del, then a starting state Q0 and a set of final states F. But the difference, now this is the similar definition we have for DFA also. But you might be thinking, what is the difference between NFA and DFA? Well, the difference lies in the transition function del. The difference is that in DFA, for a current state and the input, we have a fixed next state. That is, for every current state and that input will have a fixed next state. But whereas NFA, the next state is chosen randomly from a set of next states. Okay, so this is the difference between NFA and DFA. Alright, now let's look at an example. Let's say we have to construct an NFA over here for accepting all strings ending with 0, 1 over the alphabet 0, 1. Okay, so we are given an alphabet, it is 0, 1. And what is the condition over here? That the string should be ending with 0, 1. It should accept all the strings that end with 0, 1. Okay, so let's say this is our starting state. Let's call it A. Okay, and this is the starting state. So we have to draw an arrow, incoming arrow. Alright, now if you get 0, you go to state B. Okay, and if you get 1, you go to state C. And we'll make this state C our final state. Okay, and we can give input of 0, 1 over here because we don't care what it starts with. We only care about what is it ending with. So it should always end with 0, 1. Any other string that doesn't end with 0, 1 shouldn't be accepted. Now you might be thinking there are no trap states. That is, we have not mentioned what happens if you get a 0 over here, if you reach B. Okay, that is because your NFA doesn't need trap states. It can be complete even without the trap states. Okay, so this is the difference between NFA and DFA that we have seen in the previous tutorial. Alright, so let's try to pass a string over here. Let's pass a string 1, 0, 1, 0. So let's say we get a 1 over here. Okay, we get a 1 over here in state A. Where do we go? If we get a 1, we go from state A to state A, correct? Because if you get a 0, you go to B, but if you get a 1, you stay in state A only. If you get a 0, then you can go to either state A or state B, correct? Because if you get a 0, you can stay in state A or you can go to state B. Alright, so let's divide this into 2 parts. You can either go to state A or state B. Okay, what happens after that? If you get a 1, if you are in state A, you still are in state A only. Okay, so this was for 0. If you get a 1 in state A, you are still in state A. But if you get a 1 in state B, you go to state C. Okay, and what after that? If you get a 0 in state C, you go to null. Okay, if you get a 0 in state C, you don't go anywhere, right? So you'll write it as null or empty state. Whereas if you get a 0 in state A, you are either going to be in state A or state B. That is, if you get a 0, you are going to either be in state A or state B. Are any of these final states are any of these 3 states final states? No, they are not. So hence this string is not accepted. Okay, now let's try another string. Let's say 0, 1, 0, 1. Okay, yeah, 0, 1, 0. Okay, so let's say if you get 0, 1, 0, 1 over here, that is, first you get a 0, you are in state A, you get a 0, you go to either state A or you go to state B, correct? You either go to state A or you go to state B. And if you get 1, then you go from state A to state A itself. If you get a 1, you go to state A itself. But if you get a 1 in state 0, state B, you go to state C. Okay. Now, after that, if you get a 0 in state A, where do you go? You again go to two states, that is either A or B. Either A or B. Okay. And in state C, if you get a 0, you go to empty state. Correct? Because there is no condition mentioned over here that where you go from here. So it's an empty state. Now in state A, you get a 1. Where do you go? If you get a in state, that is, if you get a 1 in state A, you are still in state A. Correct? But if you get a 1 in state B, you go to state C. Now, are any of these states final state? Yes. C is a final state, correct? So hence this string is accepted. Okay. So this was the example for constructing an NFA that accepts all the string ending with 0, 1. Alright. Now let's try another example. Now we have to construct an NFA for accepting all strings starting with 1 over the alphabet 0, 1. Okay. So what is the condition? We are given an alphabet 0, 1. And the only condition is that the string should, all the strings that are accepted should start with 1. Okay, fine. So let's say this is a starting state. We'll call it A, starting state. Okay. If you get a 1, you go to state B, and we are okay with it. So let's make this our final state. That's the only condition. So after that, if you get anything 0 or 1, we don't care. We are fine with it. What about if you get a 0? Then do you have to take it to a trap state? No, because this is NFA. There is no need to construct trap state in NFA. Okay. So let's try an example. Let's say we'll pass a string 1, 0. So let's say we are in state A, that is the starting state. Okay. You get an input of 1. You go to state B. Okay. Now we are in state B. You get an input of 0. You are still in state B. So we have passed a string 1, 0 over here. Now we are in state B. Is B a final state? Yes. So this string is accepted. What about let's say 0, 0, 1. What happens then? If you are in state A, that is starting state, and you get an input of 0, where do you go? It's not mentioned. So you directly end up in empty state. So this string is not accepted. Okay. Now what about, let's say 1, 1. So let's say you are in state A, you get an input of 1, you go to state B. You get another input of 1, you are still in state B. Okay, you are still in state B. Now is B a final state? Yes. So this string is accepted. So this was an example for constructing an NFA that that accepts all the string that are starting with 1 over the alphabet 0, 1. Alright. Now the next example is we have to construct an NFA for accepting all strings containing 1, 1. Okay, over the alphabet 0, 1. So first we had seen something that ends with, what was that, 0, 1? Correct. Yeah. And then we had seen something starting with 1, and now we have all the strings that contain 1, 1. Okay. So let's say our starting state is A. Okay. And in this starting state, you get anything. We are okay with it. But the only thing is it should contain 1, 1. Okay. So we'll write this 1, 1 over here. Okay. Now see, you start with 0, you start with 1, we don't care. Okay. The only condition is that it should contain the string 1, 1. And you end with 0, you end with 1, we don't care. So we'll write it as 1, 0. Okay. And let's make this the final state. So let's try an example. Let's say we want to accept a string or accept a string like 1, 0, 1, 1. Okay. Will this string be accepted? Because it contains 1, 1, right? So let's see. So let's say we are in state A. Okay. We are in state A. You get an input of 1. You go to either to possibilities. You are either in state A or you are in state B. Okay, so because you get either 0 or 1, we don't care over here. So it can be either in state A or it can be either state B. Okay, so this is for 1, 1. Now what happens if you are in A and you get 0? What happens then? You are still in state A. If you get state, that is if you get an input of 0. Okay, now what about B? If you get an input of 0, what happens then? It's not mentioned, right? It's not. So what we'll do is we will actually reach to null state. Okay, that is empty state. Now if you are in state A right now, that is we have covered this part and this part, and you get an input of 1, you can be either in state A or state B again. Okay, so again you can be either in state A or state B. That is if you get an input of 1. And if you get an input of 1 again, what happens then? If you are in state A and you get an input of 1, then you go to state A and B again. It can be either of these two, correct? And if you are in B, you get an input of 1, then you go to state C. Okay, and that's it. All the 4 elements of our string are plotted now. Now, are any one of these 3 states final state? Yes, C is the final state. So this string is accepted. Okay, now let's try another string. Let's say we'll try simple string 1, 1. Okay, so let's say you're in state A, you get an input of 1. Where do you go? You can either go to state A or you can either go to state B. Correct? See, if you get a 1, you can still stay in A. You get a 1, you can also go to B. Okay, so 1 you get. Now after that, if you get another 1, where do you go? If you are in state A, again you can go to either A or B. Correct? So you can be either in A or you can be in B. So 1, 1. What about B? If you get a 1, where do you go? You go to state C. Now are any one of these 3 states final states? Yes, C is the final state. Correct? So this string is also accepted. So this was the 3rd example of construction of an NFA. I hope you got this concept. If you have any queries, feel free to ask me in the comment section below. Thank you. So that's it for today, guys. Thank you very much for watching. If you have any queries, feel free to ask them in the comment section below. If you have any suggestions, please write them in the comment section below. If you like the video, please share it with your friends and subscribe to my channel. Thank you very much.